Three useful trig identities that you're going to see a lot of in the trig work that we do. The first one is derived from the unit circle, okay, and it's effectively Pythagoras' theorem for a right angled triangle. So remember that we think of cos of x being associated with the x-axis and sine being associated with the y-axis. So if we think about this triangle, let's look at this triangle here. For an angle theta, we would call this bottom part here cos theta. That's 1, because our radius of our unit circle is 1, and this would be sine theta. Okay. Remember that you can think about that because sine of theta is opposite over hypotenuse, which is 1. So it would be sine theta over 1. So when we look at this, we know from Pythagoras that we have a squared plus b squared equals c squared for each of the sides of the triangle, where c is the hypotenuse. So we can actually draw effectively the same thing from here with the sine and the cos. So we're now going to have cos squared theta, so all of that squared, plus sine of theta all squared equals 1. Now, when we're using trig to make this look a little bit less awkward, what we do is we put the squared in next to the cos and in next to the sine. And what that does is it just makes sure we don't get confused about this being sine of theta squared. It's not the angle squared, it's actually sine squared. So that's our first rule, and I'll do a box around that. That's a classic one. Now this rule actually helps us to get two other important rules that you want to make a note of in your books. So the first one, the second rule that we're going to get from here, let's think about taking this rule. Let's call this 1, and let's divide 1 by cosine squared of theta. Okay, so what we're going to have is cos squared theta plus sine squared theta equals 1. I'm going to divide every term here by cos squared theta, and what you'll see, these cos squared thetas are going to cancel out and leave 1, plus sine over cos is tan, and in this case it's going to be tan squared because we have sine squared and cos squared. And 1 over cos, remember, is sec. Okay, so because 1 over cos is sec, and that's cos squared, this will be sec squared theta. Let me just move that line out of the way. So that's our next rule that we actually get. It's a nice one. So it links tan theta and sec theta together. So generally when you see this written in the book, they tend to write it either in that form or as tan squared theta equals sec squared theta take away 1. So I'll just put a box around that. And we actually get a last rule in a similar way, and that's by taking a Pythagoras type rule here and dividing by sine squared theta. Now you could stop the video here and actually try and get the result yourself. And I'll just do this nice and quick. So you're going to end up with a similar thing happening. So remember, I'm just putting the arrows here to tell myself what I'm getting each step of the way. This is actually tan, but it's upside down tan. So if you've got something that you know, well, this is upside down, it's actually 1 over the top of that thing. So it's inverted. This is going to be 1, they cancelled. And 1 over sec, well, that's cosec. And, oops, let's fit that in. So 1 over tan, remember that 1 over tan is actually cot. So that means that we now have 1 over tan squared, that's going to be cot squared, theta, plus 1 equals cosec squared theta. Okay, so that's our last rule. It actually links cosec and cot together. So often if you see equations where you have to simplify and you've got maybe tan squared or sec squared or cot squared, etc., these are what you're going to be using. So whenever you see any of these terms squared, use one of these 3 rules to help you to simplify any trig that you come across.